Hello students, welcome to Misostudy video classes. As it is clear from this first slide that this class is devoted to JEE advanced pattern questions discussions, and the topic is very important topic, that is electrostatic potential and capacitance. Fine. So, this topic is very important for all type of exams as well as your conceptual clarity also essential for this topic. Only then you can answer the questions. Fine. So, let us start the discussion. Now, I would like to mention one more thing, important thing over here. The questions that we are going to explain today, they will start from question number 6 onwards. Reason being, the first episode of these type of questions already with you. I hope few of you already revised, already working on those questions. So, in this particular discussion, it's like that, it's a second you can say episode of that particular sequence. So, let's start the discussion, and here comes your first question. Now, the question is simple, fine, it is not like that very difficult question, simple question, let us try to understand. You have two identical capacitors, fine, and they have same capacitance C, okay, as this line is itself self-explanatory. One of them is charged to potential V1 and other to potential V2. So, initially the charge was 0 on the capacitors. Now, two equal capacitors, equal means same capacity, they are connected to potential source. One is charged with the potential V1, another is V2. Accordingly, both have some sort of charge development, charge accumulation. Obviously, it is going to be different. Now, likely charged plates are then connected. What is the meaning of this? Let me explain you. Let us say this is one capacitor, just a symbolic representation, and this is another capacitor. So, likely charged plate means, let us say this plate is positively charged, this one is positively charged, and let us say this one is positively charged separately. So, connect positive charges, fine, positive charge plates, that is the meaning of this line, that like charges plates are connected. Then what is the decrease in energy of the combined system, that you have to find out. Now, till this line V2, question is simple, like charges plates are then connected, okay, it is a process. After that, I think few of you who are not regularly in touch with the concepts, means they are not revising, they will find some sort of difficulty with this line, which is the basic theme of this question. First question can come in your mind, why decrement in energy will take place when you connect same charges, like charges plates together? What exactly the cause? This question definitely will come in the minds of many students watching this video. My point is, please try to revise yourself, because if I will explain the meaning of this line, then obviously you will not put focus onto your basic approach of revision. So, please revise that, why it is that energy is decreasing, why it is not increasing, what exactly the cause. Please at least work upon these small points, that way you may enhance your understanding of this topic. What I will do, I will definitely going to be focused only on to the explanation of this solution. So, because as such no space is available over here, so what I will do, I will use this space to explain you. Now, decrease in energy of the combined system. So, it is something that if you can find out initial energy and final energy, so difference of initial and final, you can simply say this is the decrease in energy, okay. So, let me allow to write it down in this fashion. Let delta U is decrease in energy. Now, delta U is nothing but U initial minus U final. Again, few of you may think, why initial energy more, why final energy is less? Fine. Now, one by one I will write down the expression for initial and final energy, only then I will provide you the exact solution. So, from here if I am using a different color chalk and I am saying U initial is equal to half C, because capacitance is same, half C within bracket, this is going to be what? V1 square plus V2 square. Half CV square is the general result. So, it is V1 square plus V2 square. This is the initial energy of the system, I mean the initial energy of both the capacitors. Okay, let us say equation number 1. Fine. Now, final energy U final is equal to half into 2C. Answer of my question hidden in this bracket, and that is why I am specifically mentioning it. Fine. What is the meaning of connecting positive charge plates or negative charge plates? That is hidden over here. So, half into 2C, and then when you connect it, potential will be bifurcated, changed. So, that you can mention using this way, that is V1 plus V2 by 2 whole square. Fine. This is equation number, let us say 2. Now, ultimately nothing is so difficult left as such over here. Just put these value, solve it, you will get the answer. What I will do, I will write down next step at least for your understanding. So, please, delta U is equal to this 2 and 2 gets cancelled. Here it is 1 by 2 C, then this bracket minus C, then this bracket. Fine. So, let me allow to write down that C by 2 V1 square plus V2 square minus C V1 plus V2 upon 2 whole square. Okay? And from here I think solving it a very simple process. So, I hope everyone can do that. What I will mention over here, that after solving this equation number, let us say 3, after solving this equation number 3, what will happen, that C is your answer, that is 1 by 4 C V1 minus V2 whole square. So, let me allow to mention, after solving equation 3, C is correct option. This one is the correct option. Fine. So, I am only not solving just this last equation where you just have to take common terms one way out, and then you can arrange the various remaining term over there. So, this was question number 6, which we attempted just right now. What exactly the idea of the question and what exactly the correct answer. Still my question is there, why the energy is decreasing when you are connecting together like charges plates. Fine, please try to find out the solution or answer of this problem. Then comes this question, the magnitude of electric field in the annular region of a charged cylindrical capacitor. Now, this cylindrical word is underlined. Why? Actually, in your NCERT book, only parallel plate capacitor is defined as such. Spherical, cylindrical, all these type of capacitors are not specifically mentioned for your course. But if you are preparing for any competitive exam, then you cannot be selective like I will not prepare that. If some correlated topics are there, and this is a natural you can say question that can come in your mind, whenever you start discussing capacitors, a natural question can come in your mind, is it like that capacitors are only parallel plate? No, because if you examine actual circuits, TV or your laptop or your computer, like that, mobile even, you will find even your ceiling fan, fine, which is one present in this studio also, they have capacitors, and the size, shape of the capacitors is different. So obviously when you want to study some topic, you want to study it in up to some extent in totality. So I thought, just for a change, because parallel plate capacitor, every time you will at least you can think in your mind, is it like that? And say for example, one electrician is opening a ceiling fan that is attached in your school or in your home, and then you will just for the curiosity taking the look of the capacitor, and it is cylindrical or other way, not as exactly as parallel plate. Then you may think, is it like that I am studying only half of the topic? So I thought just put this question over here. Now, magnitude of electric field in the annular region of charged cylindrical capacitor. What is the meaning of annular region? It is like that, it is outer cylinder, and in this outer cylinder, this blue color is inner cylinder, dotted because it is from inside. Okay. So annular region means this entire region. Okay. I will not make this explanation very difficult. Directly I will use Gauss's law for finding the electric field. Now see the beauty of the concepts over here. You are studying a topic in this chapter and you are using that topic for various chapters. So in physics, the most beautiful part is it is a correlation of various topics. Study one topic and you will find yourself in a comfortable position in another topic. So now from here, what using Gauss law, I will mention it just so that you can feel it from where you are getting it. Using Gauss's law, fine. E is equal to 1 upon 2 pi into lambda upon epsilon naught r. R is the radius of this zone. So what is the direct result you are getting? E is directly proportional to 1 upon r. And if I am asking you what is the name of lambda, you will without even a second waiting will say line charge density. Fine, because three type of charge densities we discussed: line charge, surface charge, volume charge. Fine. So lambda is line charge density. Okay. Lambda is line charge density. Now let's start analyzing the options using this relation. Fine. If any one of you is interested to achieve this result, my best wishes are with you. Start using Gauss law. You can do that, you should do that. Fine. That way you are learning this device or not, that is not important. Important is you will learn an application of this Gauss law. Okay. So from here, what the relation we have? E is directly proportional to 1 upon r. So now let's start. Electric field is same throughout? No. B is higher near the outer cylinder than near the inner cylinder? No. Varies as 1 upon r, where r is the distance from the axis. So what I mentioned, this is your axis and this distance r is from axis, maybe here, maybe here, maybe here, anywhere. So C is the correct option. E epsilon naught 1 by directly proportional to 1 upon r, or this relation 1 upon 2 pi lambda upon epsilon naught r, because 1 upon 2 pi epsilon naught lambda are constant. So, that is why I am mentioning. Now, few of you may get confused that general relation of electric field for a point charge at any distance is given as 1 upon 4 pi epsilon naught q upon r square. So, why it is not is directly proportional to r square? Just because of this, to avoid this confusion, I mentioned Gauss law. Fine, and this is something which is just the application part of Gauss's law. If you are regularly watching our videos, then specifically we prepared 2-3 videos application of Gauss law. So, in those particular videos we explain all these things in proper depth. So, now let us move for question number 8. Now, in this question, what is given and what we are supposed to find out? A dielectric slab of thickness d is inserted in a parallel plate capacitor whose negative plate is at x is equal to 0 and positive plate is at x is equal to 3d. So, let me first draw this first line. Okay? So, let us draw the diagram over here. This is, let us say, x is equal to 0, and let us use different color chalks, and this is x is equal to 3d. Fine, x is equal to 3d. Now, in between this something is there. So, using this red color chalk, I am showing that. Now, let us read another thing. Whose negative plate is, means this is negative plate and this is positive plate. That way you can say it is negative charge. Okay? And you can say it is positive charge. Fine. Now, the slab is equidistant from the plates. So, this red color is slab, this is dielectric slab. Okay. The capacitor is given some charge. Charge means it is connected. Now, charging is taking place. As x goes from 0 to 3 d, as you are moving from first negatively charged plate towards the positively charged plate, like that it is given, then you have to check which option is correct. Fine. So, now as the diagram is with me, and I would like to mention one more thing over here, that is, in this particular problem, basically I would like to mention at this point, more than one may correct. Means in these out of 4 options, it may possible that more than one option is correct. So, keep it in mind. Why I am using this? Reason being, in JEE advanced pattern, they ask the questions based upon these type of concepts, like only one correct, more than one correct, matrix match, integer type, analytical type, and so on so forth, and nobody knows next time what they are going to follow. Every time IITs are free to design their own question paper. So, more than one may be correct option. Let us start analysis over here. So, it is Q, it is also Q. No problem. Now, what will happen? Induction effect will take place over here. So, it is positive, 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 negative, negative, negative. Fine. Now, what will happen? That electric field outside is going to be like this way, in this fashion. Fine. This way, these arrows are showing you the electric field, and inside the dielectric the field is like this. Few of you may get confused, I know that. For this dielectric, please revise the basics. Fine. Now it is E naught by K inside this. K is dielectric constant basically. Now one more possibility is, let us say, as it is mentioned, equal distances. So it is x is equal to d, this red line, and this red line is x is equal to 2d. Basically it is x is equal to 0, it is x is equal to d, it is x is equal to 2d, and it is capital X is equal x is equal to 3d. As it is mentioned in the question that this dielectric plate or material slab is inserted at equal distance, so that is why I am following only that particular parameter. Fine. So d, 2d, 3d and 0. Now one thing is crystal clear from this diagram, that electric field lines are in one direction. Okay, and I am not talking resultant, I am talking inside and outside type of thing, and same type of arrows, I mean same color arrows I am using. Fine. So from here what I can say, direction of electric field is same. First statement, just for your understanding, direction of E is same. Another is electric field lines, rather than writing that long sentence, I am simply mentioning electric field lines are always from higher to lower potential. Fine. Now let us try to read these options. The magnitude of the electric field lines remains same. No, I not mentioned that, I talked only about direction. Okay. The direction of electric field lines remains same. Yes, correct. Next, the electric potential increases continuously. Wait, then we will analyze. The electric potential increases at first, then decreases and again increases. Now this is something that is not possible. First increment, then decrement and again increment. That is not possible. Fine. Now in order to check C and D, what I will do? I will draw another small graph type of thing. Fine. For this particular arrangement, I hope this entire process is clear to you, and also it is now part of your video, so you can watch it at any point of time. Let me allow to erase out, so that I can elaborate point C and D also. Fine. And what is that particular situation, that I am going to explain you. Now let us talk about potential, because here we have to emphasize on potential. In two first lines we emphasized on field, and now it is potential. So let us start this discussion. Let us plot a graph. And if few points of this graph are not clear, it means up to some extent you have to brush up your basics once again. Fine. What is that situation? D, because it is 0, then 2D, and then at equal spacing it is 3D. So 0 to D, D to D, 2D to 3D, that is again D. So this interval is D, D and D. Okay. Fine. This is one way of saying about the electric field. Fine. Now let us talk about the potential, and here I think I should use a different color chalk. So it is x, because everything is varying with the x axis, and it is potential B. So, red color line is showing voltage or potential, and this is distance. Now, what is happening on? And if you just match these lines, you can say it is enhancing, basically it is enhancing, fine. So, it is D, it is 2D, it is 3D. Okay. Now, it is O, it is A, it is B. Actually, this diagram is slightly in this fashion. Let us say this way, and then slightly enhancement. So, this is the way of enhancing, fine. So, A, it is B, it is C, O A, O B, A B, like this, these points are like this. Now, listen carefully. O A parallel this B and C, okay. O A and B C are parallel. O A, if it is not visible from this diagram because I am drawing it in freehand situation, so some variation is possible, but the situation is like this. O A is parallel with V C, and slope of O A is greater than slope of A B. Next line, slope of O A, O A means this slope, slope of O A is greater than slope of A B. Slope of O A is more than slope of A B, fine. So, because of this reason, EOD is equal to E2D minus 3D. So, this field and this field, so therefore, EOD is greater than ED minus 2D. Okay. So, on the basis of this analysis, we can say that electric potential increases continuously. Yes, it is increasing continuously. So, now both way I tried to explain you why you should not consider any option and why you should consider another option as correct option. So, from here you can say this B is correct and this C, both are correct. Now, let us move ahead for the next problem. This problem was not difficult anyway, but yes, up to some extent what exactly is required over here, that is some sort of basic understanding that is required. So, now let us move ahead with question number 9. A parallel plate capacitor is charged and the charging battery is then disconnected. Now, there are two possibilities. Forget about this question right now, listen about those possibilities. I have this capacitor without any charge. Now, I can connect this cylindrical capacitor and will provide the charge. Okay. Now, if I will remove the battery, what will happen? That you should know. And this thing will be in terms of charge and potential. If you remove the battery, it means potential is something that is bound to change if you will do something with the geometry of the capacitor, but charge remains same. But if battery is connected and you are doing some sort of changes with the geometry of the capacitor, then potential is fixed, but charge will change accordingly. So, these two situations are very important and this question is based upon this theme only. If the plates of the capacitors are moved further apart by means of insulating handles. Initially, parallel plate capacitor was like this, in between dielectric is there or something and it is fully charged. then remove the battery. Remove the battery means now potential will change but charge will remain. So now do this, enhance the distance between the plates. So it is like that, this is one plate, this is another plate, and the gapping between the plates is like D. Fine. So just keep this simple situation in your mind. Let us try to find the solution. And this question also comes in the category of one or more than one. One or more than one correct. Because with the help of just one question, I am trying to explain you at least 2-3 concepts. Fine. So what exactly is the situation? As potential source means battery, as potential source is removed, so charge Q is constant. This is first outcome. Okay. Now, if the plates of the capacitor are moved further apart like this, D is increasing. So what is the meaning of this? So as D is increases, as D is increases, so what will happen with the capacitance? It will decrease. So as D is gapping basically. So as D is increases, so C means capacitance value, C decreasing. Why? Because C is equal to K epsilon naught A by D. Let me allow to write down it. C is equal to K epsilon naught A by D. If K and epsilon constant, put them aside. So if D is enhancing, then C is decreasing. More denominator, less this outcome. So these two lines are just giving you the basic fundamental thing which is happening on. Now let us move ahead. Now V is equal to Q by C, basic formula. Now V is equal to Q by C, but Q is constant, first line. C is decreasing, so this V should increase. Now V is equal to Q by C, and if I am directly writing V is increasing, so I hope now nobody will say why. Reason, Q is constant mentioned here, C is decreasing mentioned here. So denominator reducing, this is constant, so ultimately B is bound to increase. Fine, that is potential is bound to increase. Okay. So after these three statements, let me allow to clean up some portions so that I can further explain other related aspect of this particular question. Now first thing, on the basis of this much, let us try to read at least one or two options. Charge on capacitor increases. No, we proved at least 2-3 times that Q is something which is going to remain this way fixed. Fine. So it is not correct. Voltage across the plates increases. Third line, yes, it is correct. Capacitance increases. The electrostatic energy stored in the capacitor increases. Now you can say easily that C is correct, but I want to check D also. Only then I will reach on any solid conclusion. Okay. So let us take a look of this also. Here capacitance increases, decreases, wait for time. U is equal to half CV square, or U is equal to half Q square upon C. As Q is constant, C is decreasing, so you should increase. Why? Because Q is constant, C is decreasing, therefore you will increase. Fine, you will increase. So capacitance increases, electrostatic energy stored in the capacitor increases. It is incorrect, it is correct. Why? Because it is what? It is decreasing basically. Fine. So now you can say option B and D are correct option for this particular question. The question was not a very difficult, but it was associated with lot of you can say understanding of the concepts. Now my simple suggestion and request to all of you is kindly revise, kindly revisit this question, kindly try to handle this question assuming that battery is connected and then plate separation or closing is taking place. Try the same problem, but assume that battery is not disconnected. Once the capacitor is fully charged, then it is like this, and in this situation charge will not remain constant, potential will remain constant, because potential is coming from your source. So here comes your question number 10. Capacitance of a parallel plate capacitor with plate area A and D is C. Okay, this is D and this is A, plate area. The space between the plates is filled with two wedges of dielectric constant K1. This is K2 and this is K1. Two types of dielectric slabs are inserted. Find the capacitance of the resulting capacitor. It is a simple question, but just because of the insertion of these two type of this dielectric material, and that too in a specific fashion. So now it is not one capacitor, but it is a combination of two capacitors connected in series. Capacitor C1, this entire portion, one capacitor, and this entire portion it is C2, and both these are connected in series. How? I am going to explain you with the help of a diagram. This is this portion, and now what exactly I am doing? I am basically doing, what I am doing, let me show you here also, this line, and then I am saying let us assume this portion, and then we will integrate it from this point to this point for this and this. Okay. So same thing I draw over here. Let us say this small gapping is equal to dx. Okay, this strip is of thickness dx. Okay, and this is P, and this is over here it is Q. Fine, it is Q, and I think let us make it R. Fine, let us make it R, and it is Q, this point is Q, and this angle is theta, and this is x. I hope this much is clear to you. Now QR is equal to x tan theta. QR is equal to x tan theta, and PQ is equal to d minus x tan theta. Fine, simple relations using algebra I mentioned. So now from here one thing I can say, but tan theta is equal to d by L. Tan theta is equal to d by L. Now capacitance for PQ, that is upper portion, and capacitance for this QR. Okay, so C1 for PQ, that is capacitance for PQ, C1. So final expression if I write down for C1, then it is K epsilon naught A dx, this thickness, but we have to expand it, upon dl minus x. For this expression, to get this expression, yes, up to some extent you have to work. So now use this C1 which is mentioned over here. Let me allow to erase this portion so that I can write down C2 also. Okay. That is C2 for this is QR, fine. So C2 for QR. Directly I will write down the value for C2. C2 is equal to, it should be K1. C2 is equal to, in the same fashion, K2 epsilon naught A dx upon x into d. Only denominator is different. So K2 epsilon naught A dx upon x into d. Now, as you know, also I mentioned over here that C1 and C2 are connected in series. So series means net capacitance is 1 upon C net is equal to 1 upon C1 plus 1 upon C2. Okay. That is, as C1 and C2 are connected in series, so 1 upon C net is equal to 1 upon C1 plus 1 upon C2. So finally C net is equal to, what I can write down, C net is equal to integral, I am writing it just because this is something that I will get for that small strip dx. So we have to expand it, fine. So C net is equal to how much? That is 0 to L, let us give it a different name, C final, and then put C net over here. And what is the expression for C net? That is C net, you can easily get by solving it, epsilon naught A K1 K2 dx, obviously that gapping, C epsilon naught A K1 K2 upon dx into d within bracket K2L plus, that is K2L for this second capacitor. So d K2L plus K1 minus K2x. So this expression is slightly long, but if you easily solve it, you can get it. Finally, put this value over here and integrate. I will mention the final result in this fashion. Process I explained you, calculation you have to do, and in JEE advanced pattern, if you are preparing for that, you should be ready mentally for long type of questions, fine. So finally C final is equal to C K1 K2 upon K2 minus K1 ln K2 by K1, where C is equal to epsilon naught A by D. Yes, this question number 10 was slightly long question, but I provided this question, I discussed this question just to emphasize on a point that mentally you should be ready for some difficult long questions also, fine. So with this, students, I would like to say first thanks to you for devoting your precious time for me, for watching this video. From Misostudy, once again, take care of yourself, keep revising. Thanks a lot.